Hello, welcome to the video lecture series presented by St. Andrews Institute of Technology and Management. My name is Ravinder. I am an assistant professor with ETC department, and in the series of lectures we are discussing the subject of object technologies and programming in Java, that is OT&P. Now we are discussing an important topic for past few lectures, that is exception handling, and we are at the cusp of let's say concluding the exception handling topic. This would be my final lecture on the exception handling, and we have left with two final topics to discuss in this particular lecture. The first one is using finally, and the last one is I will show you how to create your own custom exception class. Okay, so first I will talk about for a few minutes about the finally keyword. Now, as we have discussed in the last few lectures, sorry, as we have discussed in the last few lectures, that whenever we encounter an exception, the control will switch from the particular try block to entirely to the catch block. Now, there is one more thing that I haven't told you yet. When I say that the control will switch from a particular try block to or I can say the try block to a particular catch block, it is not like I'm calling a catch block. That you might have seen that when we call a particular function or when we call or use a particular method by using some object in a particular class, what happens is the controls for some time switches from that particular class to the method that we have called. Okay, and when the method let's say finished doing what it is meant to be done, meant to do, it returns the control back to the class, and class will resume its operation exactly from where it has left. This is not the case in exception handling. In this case, the control is not being suspended by the class. It has been permanently transferred from the try block to the catch block. And after the handling of the let's say after the handling of the exception, the control will not go back to the try block. So let's say in the try block we have a few lines of code, let's say 5 lines of code, and an exception uh, is generated out of the second line of code inside the try block. So in that case, if that exception is caught either by the Java runtime environment or by an catch block, the remaining 3 lines or 4 lines of code inside the try block after the line from which the exception has been generated will not execute, and the code will go on executing the lines which are after the catch block. And if that particular exception is not being caught by the catch block, in that case Java runtime environment uh, will catch that particular exception, and it will print these particular stack trace, and your application will be terminated then and there. Okay, so there is a difference in calling a method and let's say the transfer of control from the try block to catch block. While using try and catch block, the transfer of control will not happen back to the try block. While calling a method, the transfer of control takes place between the calling method or and a particular class or object. Okay, so it shifts between them back and forth, but not in the case of try and catch block. Now, why do we use a finally keyword? Suppose like we have discussed that the case we have discussed, Let's write something. Let's say we have a try block, and I have line 1 code and line 2 code and line 3 code. Okay, and I will close this try block, and after that I will write the catch block. The catch block will caught the exception, and it will have a body, so I'll not go into the what is inside the body of the catch block and what kind of exception it is going to trace. I am just concerned with this particular block here, that is these 3 lines of code. Now suppose the exception has been generated out of this particular line of code, that is line number 2. Now this is a syntax line number 2. By line number 2 I just mean that a line syntax in Java has been written in this particular line. It is doing something and an exception has been generated out of it. And as you know, when the exception has been generated out of this particular line, the control will automatically shift to this catch block if it is meant to catch the exception which has been generated by this particular line. So let's suppose it is meant to. So we can say that when the exception is generated out of this particular line, the control will automatically shift to the catch block. Okay, now whatever you have written inside the catch body will execute, and then after the control will shift whatever you have coded outside the catch block, and it will not go inside the try block again to execute line number 3. We have just discussed that a few seconds ago. Now what I'm trying to say is, in some cases you want this particular line to be executed at every cost, whether an exception has been generated out of the other lines of code or not. Okay, particularly in the case of input output streams, particularly in the case of input output streams and file handling. Now we haven't gone to that topic yet, but let me tell you that if you have opened up a file, it is must that after doing the operations on that particular file, you must close that particular file while using Java. Or if you have opened up a stream object, then you must conclude the streaming, or you must end that particular stream after you are done sending the data over that particular stream. That is, I am talking about input output. If you are trying to send some data over the stream using the Java, then you must have opened up a particular stream, and at the end of your operation you must close that particular stream. Now suppose line 1 actually opens up a stream or a file, line 2 actually does some operation on that particular file, and line 3 actually closes that file. And unfortunately, if an exception has been generated out of this particular line 2, then line 3 will never execute, because control will finally be handed over to from line 2 to the catch to the catch block directly. Okay, and line 3rd will never execute, so your file has never been closed, and this may amount to compilation error while executing this particular class. Okay, so what I'm trying to say is, in those cases where it is utmostly important to execute the few lines of code, even if that exception came out of the try block before that particular code or not, we use the keyword called finally to execute those kind of operations. Okay, so what we'll do is we'll remove this particular, we'll remove this from here, and I will put the keyword finally, and inside that I will paste this line. Now if this particular exception out of this particular line generated or not, the finally line will the the block of code which has been written inside this finally block will execute at any cost. Okay, so this is a small application of using the finally. So finally is mostly used while dealing with input output streams or handling files. Okay, uh, I will show you the example of finally when we are dealing with the input output streams in next unit after few lectures. But right now I will not show it here because it will not going to understand what I am trying to do here. Okay, so this is the basic concept of finally when we got there for handling a particular file. I will tell you to just recap this particular lecture, that is the finally, and after that we will see an example of the implementation of finally keyword in Java. Okay, especially for exception handling. Now, exception handling find its implementation especially while dealing with input outputs. Okay, so we'll see a lot of exception handling in next unit. Now the last topic that we are left with is creating custom exception classes. So let's see how can we create a custom exception class and try to implement it and see if we are able to let's say caught the that particular custom exception or not. So let's get, so what we'll try to do is, let me first create a class. Now let's say my main third class. Okay, and public static, sorry, static and void main. Okay, so basic stuff you have seen, you must have seen that so many times. So these must not be. Okay, so we have created a class called my main third and we have initiated a method called the main method, and like in the last lecture we'll again try to divide the element wise, or we'll try to perform the element wise division of the elements of two arrays. Okay, so let's initialize or declare and initialize two integer arrays. And let's say x61 again, and I will hard code these values here. 1 2 3 4 5, and let's say one more, and I'll name it x62, and one cause. Okay, so we have two arrays here, and we'll see how we can divide each element of x61 with each element of x62. So for that, for traversing each element of x61 and x62, we have to use a for loop. So for loop, and equal to 0, and I must be less than x61 dot length, and I plus standard for loop. Must have seen that many number of times now. Okay, and I will initiate the try block inside this for loop, and after that I will initiate a catch block, the arguments and the body. Okay, now I left it here, I will not write anything, and okay, I will do one more thing. Let's say we want to define an exception that whenever the division of an element of x1 by the element of x2 results in a non-integer value, that is, the division of an element of x1 by the element of x2 results in a floating value, we want to flag that particular event as an exception. Okay, now let me remind you that no such type of exception has been predefined in Java runtime environment. In Java runtime environment. So we have to customize exception class for this particular type of event. Okay, so first let's initiate a if block. Now if element of x1, let's say I, division by xx, this xx2 close this and percentage 2, that is the remainder operation. This. And is not equal to 0. Okay, so why it is okay, I will return this. So what I have done here is, if I divide an element of xx1 with an element of xx2 and the resultant after the division by 2, the remainder doesn't came out to be 0, then we can infer that this particular division results in a non-integer value. Okay, let's suppose 1 divides by 1, the result will came out to be let's suppose 1, and if I try to divide it by 2, the remainder is not equal to 0. That means that the result of this particular division is an odd value. Okay, so let's try. Now we haven't yet declared the exception class, or we haven't written any exception class yet for detecting this particular, or for catching this particular type of exception. So first we'll try to do that. Now you must have remembered the keyword called throw, which we have used to generate or throw an exception manually. Okay, so I'll use this particular keyword here and throw new, and we haven't written an exception class, so I will name that particular exception class as not int exception. You can name it as you want. Okay, argument, and this not is showing me red signs because I haven't created that particular class. So let's write this class first. So I'll write class not int exception, and this particular class will actually extends the exception class. Okay, that is it. So to create a custom exception class, all we have to do is just create any class with some name, and it must extends the class exception. Now you must have remembered that all the exceptions have one superclass called throwable, throwable, throwable exception class, and that throwable exception class, which is the super class of all the exceptions, has two subclasses. One is error subclass, which we are not talking here, and that is beyond our control to handle those kind of exceptions. And second subclass was exception class, and that exception class then again has a subclass called runtime exceptions, and in that runtime exception subclass we have all those exceptions declared, that is arithmetic exception, divide by zero exceptions, and all that, which we have seen already in last few lectures. Okay, so our custom exception class must extends the exception class, which uh, actually extends the superclass called throwable class. Now, this particular exception class doesn't hold any or doesn't have any kind of methods, but because it actually through exception class actually let's say extends the throwable class. The throwable class have some methods which we can override here. So I'll try to override one. At first I will declare some variables called int a and int b, and I will try to try to initialize the constructor not int exception. Okay, and let's say int a comma int b, and you must be familiar with constructors at this point. I think is equal to a, and this dot b is equal to b. Okay, so we're done here, and now I will try to override a particular method which has been defined in the throwable class. But because, and how can I override it here? Because we are actually extending a class exception, and this class exception actually extends that particular throwable class. You must be familiar with the extends keyword. We have already covered that in inheritance. So let's say sorry, public string to string. Okay, and write body conditions. Oh yes, I will. So let's say return, and I will return something like let's say a and plus let's say divide plus b plus integer. I'll write is not an integer value. It's not an integer value. So we have overridden this particular method to string. Let me remind you that again, this particular method is being defined inside the throwable class, and I am able to override this particular method here because the throwable class has been extended by the exception class, and this particular class has extended the exception class. So we are legally allowed to override the method. The method overridden has already been discussed in the inheritance unit or unit 2nd. So now all we have to do is just pass the two arguments which are supposed to be passed. You can see here in the constructor we are supposed to pass two arguments to the object of not int exception class. So what I'm going to pass is xx1 and that's I comma xx2, let's say I, and okay, I think we've got this. So let's pass the argument of type not int exception E. Inside this I'll write system dot out dot println, and I'll write okay. Let's say we have got it. Got it. Let's see it. Okay, and let me change the zero value. I don't want anything messing with us right now. Okay, now I have made few changes to this particular code, as I will not show you while making those changes, because then the video will be too long. So I'll try to conclude this. What changes what I have made here? First of all, I have made some data changes, because previously those data will each one of those data will end up in generating an exception, and we don't want that. Secondly, I have changed this condition here. So previously I have made that condition too complicated, but now it is quite simple, that if xx and the element xx1i when divided by xx2, if the remainder is not equal to 0, then you can conclude that the division is going to be an non-integer or the floating point value. Okay, and that is all the changes that I have made here. And I have also used this particular object here. Now when you try to print this particular object here, you actually be getting what is printed, what has been returned by this particular method here, toString method. Okay, so we'll see it. Let's try to run this particular class, and let's go to the console. Okay, now you can see that we have actually succeeded in developing a custom exception class, and it has actually succeeded in throwing an exception, and we have actually caught it. So you can see that only two data combinations are there, that is when we have divided 2 by 3, then the result must not be an integer, and we have caught it. And next one is when we try to divide 3 by 2, the result must again be a floating point number, and we have also already caught it. Now the printing style is, when we are inside this catch block, we will try to print we have caught it. That's what we are seeing here. And next is after a new line, which is indicated by this escape sequence, you can see we are actually trying to print this object E. Now this object E will print whatever be returned by this particular method, and as you can see, this method returns that the number A divided by the number B is not an integer, and that is what has been written here. So the point is not what logic you have used here. My main point of view is that you must understood how to write an exception class, and how then you will manually allow it to throw an exception, and how we are going to caught it, and how to use this particular object that we haven't seen yet. Okay, so I'll conclude my lecture here. You can practice some more customized exception classes of your own. You can give up some idea that okay, this particular event could be an exception, you want it to be an exception, then you can write a particular class which extends the exception superclass, and then you can throw the exception manually using some condition, and you can then easily evaluate if you have succeeded to caught that particular exception or not. Okay, thank you.